Hi everybody. So this is a continuation of 5.1, which is about functions. So make sure that you watch part 1 first. This is really part 2. We're going to talk about the same ideas that we saw in the first part, but we're going to see them in some applications. Okay, so this is mostly applications of function notation, but we are going to still use some ideas about functions. Okay, so let's look at the first example. The Sears Tower in Chicago is the third tallest building in the US at 1,454 feet. If a camera is dropped from the top, its height above the ground after t seconds is given in feet by this equation. Okay, so what's nice about these applications is they're actually giving you the equation. So unlike what we saw in the very first section that we did in class where you guys had to come up with the equation yourself, these are mostly going to give you the equation and then ask you some questions about it. Okay, so here's where we get into our function notation. The first part says find h of t, or h of 2, sorry, and what does that mean? Okay, so what we're going to do, if you'll remember, right, this number here is a value for t. So what we're going to do is plug in that value for t. Okay, and then we are going to find out what that is equal to. Okay, so just using my calculator here, I got h of 2 is equal to 1,390. Okay. All right, so that's the part that uses function notation. Now here's the second part of the question. It says, what does it mean? Okay, so your answer to this should have two parts. Okay, you want to say, what does the 2 mean? And then what does the 1390 mean? Okay, so remember 2 was a value for t. Okay, so this t value is t seconds of being dropped. Okay, so I might explain this in words by saying after 2 seconds, okay, because t is time, and that's explaining what the 2 means. Okay, and then what does this h of t mean? Well, that's the height. Okay, remember, see, it says it's height above the ground. Okay, so we would say the camera is 1,390 feet above the ground. Okay, so our explanation is explaining the 2 after 2 seconds, and it explains the 1390. The camera is 1390 feet above the ground. Okay, so make sure that in your answer about what does that mean, you're including both important parts. Okay, so we're going to do a real similar question here. Find h of 1. What does it mean? So if you're doing this at home, I encourage you to pause the video and do this one yourself. Okay. Now, if you've unpaused, you've already done this, you know that we need to plug in this 1 to our function. Okay, 1 is a value of t, so we're going to plug in 1. Like that, and then we're going to evaluate this. Okay. So I got 1438. Okay. And then we're going to explain what this means. So again, the t value, which is 1, is time. So this is going to be after 1 second this time. Okay. And now the height is 1438. So we would say the camera is 1,438 feet above the ground. Okay, so this what does it mean is really asking you if you understand what the two variables are standing for. So do you understand that this 1 is the time? And do you understand that this h of t value right? 1,438. Do you understand that that's the height? Okay. All right. Let's look at part C. Okay. For what values of t is h of t 158? What does that mean? Okay. So first we're just going to solve the part that says for what values of t is h of t 15 or 158? Okay. So we're going to, just like we learned in the previous lesson, when we have this, we're going to substitute 158 for the whole expression h of t. So we'll have 158 equals minus 16t squared plus 1,454. Okay, so now, because this is an x squared type of equation, we're going to move everything to one side and try to solve this by factoring. Okay, so I'm going to subtract 158 from both sides. And that's 1,296. Okay. Now I'm going to give you a tip about these falling object problems. It's always beneficial to try to factor something out here. Okay, so we're going to check if 16 goes into 1296, and it does. Okay, so we're going to factor out this negative 16. And we get 81. Okay, now I didn't just know that, but I know it's even, so it's at least divisible by 2, and I want to divide out as much as possible to make solving this as easy as possible. Okay, so what I'm going to do now, okay, so remember this is what I had on the previous exam, or on the previous page. Okay, is I'm going to finish factoring this. Okay, so I know that this is going to factor like t plus 9, t minus 9. Okay, and then I'm going to set each of my factors equal to 0, just like we saw in Algebra 1 when we were solving these types of equations. Okay, now we have to do something here, okay, and this is because this is a word problem. Normally, both of these solutions would be totally fine, and we would just say, like we saw in the first part of this, that there's two values where h of t is equal to 158. But we have to think about what t means, right? T is time. So if you think about -9, that would be 9 seconds before the person has dropped the camera. So if they've not dropped the camera yet, it certainly hasn't fallen down to 158 feet. So in terms of our word problem, that really doesn't make sense. Now this means 9 seconds after they've dropped the camera. So that does make sense, and this is going to be our solution for this problem. Okay, so in general, these would both work, but because we're talking about a word problem, we need to assess them both for reasonableness, right? And we know that before you drop the camera, you're certainly not going to have it having fallen all the way to the ground. Okay, so the second part of this question said, what does that mean? Okay, so first we're going to say what the 9 means, right? So remember t is time, so we're going to say after 9 seconds. And then remember h of t is the height. So we would say the camera is at 158 feet above the ground. Okay. You'll notice that our answers for what does this mean are all very similar, and that's because we're talking about the same situation, right? We're talking about a fallen camera. So all of these questions are going to be after a certain period of time, the camera's at a certain height, right? And that's really coming from the wording of the question, the original question about dropping the camera. Okay. All right, let's move to our example 2 that has a very different type of function. Okay, the function given by the table below gives the cost C of shipping as a function of the cost of the merchandise M. Okay, now the first thing I want to point out is this language about as a function of the cost. Okay, so remember when we talked about writing an equation for something in terms of something else? Okay, this is exactly the same. We're just using function language now. So now instead of saying we're writing cost in terms of m, we're saying we're writing cost as a function of m. But it really means the same thing, right? That cost is the output and the input is the cost of shipping is the output. The cost of the merchandise is the input. Okay, so let's look. This is a function expressed as a table. Okay, so here's the cost of the merchandise, the input variable on the left. And you see it gives a range for the values. Okay, and then it tells you the exact cost of shipping here on the right column. Okay, so let's answer some questions about that. We'll go back to that in a second if we need it. Okay, so the first question, part A, says find C of 2150. Okay, so this 2150 is an input, right? That's a value for M. So we're going to look at ours and we're going to look at where 2150 would fall into. Okay, so I'm sure you guys can see that 2150 falls into this range between $20 and $30. Okay, and that would mean that the output associated with that is here. Okay, so that would be our answer. It gives us the input 2150, and we're going to give the corresponding output from the table, which was 585. Okay. This question doesn't have any computation. You don't have to actually plug anything in. You just need to give the corresponding output based on the table. Okay, so this question is really getting at, do you understand the function notation versus can you add and subtract? Okay, so if you're doing this on your own, I want you to pause it and you are going to find C of 100. So I will put the table here for you so that you can see, okay, those ranges of the price. So you are finding C of 100 here. Okay, so let's assume you've decided. Okay, now 100 is interesting because it's right on the border between this column and this one. Okay, so we're going to determine that it should be in this row because this says over $100. Okay, so this is really going to start at 100.01, whereas this one includes 100. Okay, because of that, we're going to see that this is our corresponding output. So that's what we're going to give us our answer. So C of 100 equals, okay, remember the formatting of your answer is important. You do want to format it like this. Repeat the question and then says equals and give your output. So here C of 100, and then we're going to give our output that we saw on the previous page, 970. Okay. All right. Let's look at the next type of question, which is a little bit different. What is the smallest value of M so that C of M is 585? Okay, so now they're giving us a value of C of M. Okay, so we're going to look at our table and we're going to look for 585. Look, you can see that we already have it circled. Here it is. Okay, so they've given us this value. And they want to know what is the smallest value that would give you that answer. Okay, so if we look at this, what's the smallest number that would correspond to that? Okay, the smallest value in this range. Okay, so to me, that number is exactly here at the beginning of the range, 20.01, right, or $20.01. Okay, so remember, if we're finding M, our answer is going to look like M equals, and then we're going to give the value that we found, which was 20.01. Okay. All right. Find all values of M so that C of M is 585. Okay, so again, they're giving us this value 585. So we're talking about this row here. And they want to know this time not the smallest value of M, but all of the values of M. Okay, so that's going to be this whole range that we're looking at here. Okay, so we're just going to say M is between 20.01 and 30. Okay, and that's how we're going to describe that range, right? Between 20.01 and 30. If you want to use an inequality, you certainly could. Okay, if you're comfortable with that, but I'm also comfortable with your answer being in words like this. Okay, so either one of these answers is totally appropriate and you should go with your comfort level. Okay, all right, those are the examples I wanted to do for this section, so I'll see you guys soon.